Good day, everyone. Welcome to EEE137. This is our first week of discussion for this course. And for this video, I will be discussing a specific problem in our third set of activities for this week. So the problem that I am going to discuss is the Marksman problem. So this is a specific problem in the discrete random variable. Okay, so let me first read the problem. Okay. Marksman takes 10 shots at a target and has a probability of 0.2 in hitting the target with each shot independent of all other shots. Let capital X be the number of hits. So capital X will be our random variable. So let us try to solve this problem. So we present first the given that we have. So number of shots available for the marksman. Okay. We could indicate that, or we could define the shot here. Okay, as our trial. Okay. The, the trial in our stochastic experiment. So we have 10 trials for the marksman, so the number of trials available is 10. And then hit here, or the probability of hit here, denoted by P is equal to 0.2. We could represent that as the success in our specific trial. So out of the 10 trials, okay, we are trying to hit the target, we represent that as a success. So on the opposite side of that, if the marksman misses the target, that is indicated as a failure. Okay, so the probability of that happening, if we could recall, there are only two possible outcomes for each trial. That is a Bernoulli random variable. Okay, so um, the probability of that happening is 1 minus p, 0.8 basically. So that is a failure. Then finally, we have our random variable, capital X, okay, which is the number of success out of the 10 trials that we have. So that is our random variable. Okay. So the first problem in our, or the first question in our problem is we have to calculate and sketch the probability mass function of that specific random variable. So for us to be able to do that, we first have to define the sample space of our stochastic experiment. Okay? So the sample space, very important kasi if you could recall, the random variable is actually a function wherein the horizontal axis is the sample space, basically. So, ano ulit yung sample space? The sample space is the set of all the possible outcomes of our stochastic experiment. Okay, so kung meron tayong 10 shots available for the marksman, and then our random variable is the number of success out of those 10 trials, what are the possible outcomes that can happen in our experiment? Okay, so the first possibility is that the marksman, out of all the 10 trials, he doesn't hit a target. Okay, so that random variable is equal to 0. Capital X is equal to 0 for that specific outcome. The second possibility is that out of the 10 shots available for the marksman, he's only able to hit one target. So that X is equal to, capital X is equal to 1 in that case. And we know na yung succeeding outcomes will just be the set of all whole numbers from 0, and then the final possibility is that the marksman will be able to hit out of the 10 shots available for him, he will be able to hit all targets. So there is actually a very slim chance of that happening because as you could see here, probability is equal to 2, 0.2 for each shot available. So, but then, kahit na slim chance siya, it is still part of our sample space. Okay? So now, if we are able to enumerate the different outcomes that we have for the sample space, para makuha natin yung probability mass function, we have to compute, okay, the probability of all of these outcomes in our sample space. So we have to compute the probability that the marksman will hit only 0, will hit 0 targets, okay, will hit 1 target, will hit 2 targets, up until the probability that the marksman will hit 10 targets. Okay, so we consider a specific we consider first a specific outcome in this sample space. So for example, what is the probability that the marksman will hit 2 targets out of the 10 given to him? Okay, so let us first analyze, or ayun nga, let us first lay down all of the scenarios available to us. So the first scenario, or a possible outcome, or a possible scenario for this case is the first 2 shots will be hit by the marksman. So indication ko lang is kapag meron tayong circle, it is considered a hit, and then kapag cross naman is indicated by a failure or a miss. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So ang scenario na to, okay, ibig sabihin nito, the first 2 shots were hit by the target and the last 8 shots were missed by the target. So the outcome, the final outcome of that is out of this 10 sample space, 2 yung na-hit niya. Okay? So we compute for the probability of this scenario happening. Okay? So the probability of this happening, how do we solve that? So we know that the probability of hit for each trial, for each shot available to us is 0.2. So ibig sabihin nito, for the first shot, the probability of it being hit is 0.2. Okay? And then for the second shot, the probability of it being hit is 0.2. And as I've said, the probability of failure, 0.8. So they're all have the same probability. So that. And another assumption that's important to us is sinabi dito that all of the shots are independent of each other, right? So that's a very important assumption because kapag nasabi nating independent ang dalawang events, how do you calculate the probability of both of those events happening at the same time? Okay? We just compute the product of their individual probabilities. So all of this happening at the same time, since independent sila sa isa't isa, is just the product of their individual probabilities. So we can compute the probability of this whole scenario happening to be equal to 0.2 squared times 0.8 to the 8th. Okay? So that's how you compute the probability of this single scenario happening. But we all know that hindi lang naman yan yung possible scenario wherein yung final outcome natin is 2 yung na-hit ng marksman. So we also have another scenario. So lalagay ko yan. Another possible scenario is first shot na hit niya, second shot na miss, third shot na hit niya, and then the rest is na miss niya. Okay? So ang probability dito is still the same, right? Kasi dalawa yung na-hit niya. Okay? And then 8 yung na-miss niya. Okay? Okay, so another possible outcome is circle x, circle x. Ayan. So actually, pwede nyong bilangin yung mga possible combinations natin. And then, so it's actually a counting problem right now. Okay? So we've discussed that yung counting techniques natin, right? So there is called combination, permutation. So you have to analyze what kind of technique are we going, or what kind of computation we are going to use. Combination ba, permutation, or yun nga yung 4 na combination, unordered selection without repetition, etc. So analyze natin. So with repetition or without repetition. In this case, the first shot, second shot, third shot, all of them, hindi naman inuulit yung shot na yun. Right? So, ibig sabihin na to, without repetition. And at the same time, okay, so I'll write this. First shot and second shot, even though you exchange their position, right, they are still identical to each other. Ibig sabihin na to, each bullet na ginamit ng marksman, they are all identical. So, kahit pagbalik na rin mo yung position na to, itong dalawang to, hindi nagmamata yon. Okay? So, ibig sabihin nito, unordered or position doesn't matter, unordered selection without repetition. So, yung counting technique na gagamitin natin is combination. Right? So, kapag nabilang na natin to, basically, kapag sinabi nating or, di ba? And alam natin na disjoint yung bawat scenario na to. Okay? So, ibig sabihin nito, kapag meron tayong union of these events, nag-a-add tayo ng probabilities. Okay? So, lahat ng to, same probabilities. And then, bibilangin lang natin. So, the probability x is equal to 2. As I've said, there are 10 combination to possible scenarios. Kung bibilangin mo lahat ng scenarios wherein x is equal to 2, 10 choose 2 yung total number nun. Okay? 10 choose 2, ibig sabihin nun, 10 choose 2 times mong i-add yung probability values na to. Okay? So, paano yun? So, 10 choose 2 multiplied by this probability. 0.2 squared, 0.8 to the 8th power. Okay, so that is only the probability that capital X is equal to 2. So, nasolve na ba natin yung problem? Okay, hindi pa kasi ang pinapakalculate na sa atin is not a specific outcome, pero yung buong probability mass function. Ibig sabihin, the probability of all the sample space. So, we have to generalize this. Okay? So, in general, okay, the probability that the random variable x takes on an outcome small x, then small x na to will be any of the values in our sample space. So, 0, 1, 2, 3, up to 10 is equal to, so, gamitin na rin natin yung variables natin kanina, yung number of shots and probability of hit P para ma-generalize natin yung formula. So, number of shots available for the marksman is N, and then the number of success or the number of hits that he has achieved is the outcome small x. Probability of success is P, and then the number of success is X, small x. Probability of failure is 1 minus P, and then the number of failures in that experiment is small n minus x. So, ang tawag natin sa equation na to, we all know this, is our binomial random variable. Okay? So, the binomial random variable is basically a set of Bernoulli trials wherein meron tayong fixed number of trials. In this case, n is equal to 10. And then we are trying to indicate the probabilities of the number of success in that specific fixed amount of trial. Okay, so that is the binomial random variable. So now, we can now sketch, so the random variable is a function, or the probability mass function is just a graph. Tapos, yung horizontal axis natin indicates our sample space, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And each number here, or each outcome here, has their corresponding value. Okay? So, ang y-axis natin dito is P sub capital X of small x. Yung P sub capital X of small x, that indicates the probability of this happening, So, para mag-graph nyo siya, you just have to compute this for all possible values of small x. Okay? So, I'll just show you that, the graph of that. This one. Okay? So, this is the code for that. And then this one is the probability mass function. So, as you could see here, the highest probability is at x is equal to 2. So, ayun. If we are able to sketch this, we are done actually with the first question. And then the second and third question is just similar. It's just the same. You just have to Okay? You just have to use right? You just have to use this equation. Okay? So probability, capital X is equal to, so nakalagay dito, second question, what is the probability of scoring no hits? So that outcome is capital X equal to 0. So capital X is equal to 0. So 10, choose 0, 0.2 raised to 0, 0.8 raised to 10. That probability is 0.1074. Okay, so that is for the second question. For the third question, okay, the third question is, what is the probability of scoring more hits than misses? So ano yung, so di ba meron tayong sample space, okay? So alin dun sa mga, dun sa set na yun, corresponds to this event happening. Okay? So as you could recall, event, ang definition natin ng event is a subset of a sample space. So dun sa sample space na yun, okay, alin sa 11 outcomes na to is part of the subset of that event. Probability of scoring more hits than misses. So actually, yun yung capital X greater than equal to 6. Or ibig sabihin, number of hits na nagawa ng marksman is 6, 7, 8, 9, 10. Ibig sabihin nun, more hits than misses kasi kapag 6, di ba, 4 yung na-miss niya, kapag 7, 3 yung na-miss niya, etc. etc. So for us to compute that, we just compute for the summation from x is 6 to 10 of this equation. 0.2 raised to x, 0.8 raised to 10 minus x. And the answer to that is very slim. Okay? 0.6% chance of that happening. And it's actually very or intuitive naman because the probability of marksman hitting the target is 0.2, right? So, medyo mahina yung marksman natin. So, kapag more hits than misses, medyo slim yung chance niya. And actually, dun sa graph natin kanina, okay, yung probabilities natin is mostly nakakoncentrate sa ano, right? Nakakoncentrate dito sa 0 to 5. So, kaya pag inad mo yung mga probabilities na to, very small value pa rin siya. Okay? Now, the next problem is, what is the expectation on the variance of x? Okay, so another topic to, expectation and variance. Okay? So the formula for our expectation is actually the weighted average of all the yun nga, yung sample space natin. So, wherein x here is in the sample space, tapos we multiply that by the probability value. Okay? So, that is the general formula of our expectation. Or actually, since alam natin na binomial random variable, if you are able to memorize yung mean and variance, kasi normally, di ba, they have a specific formula already, given the parameters that we have, the number of trials and the success. But para alam rin natin yung derivation or para magamay rin natin kung paano mag-solve ng expectation for a general random variable, let's try to solve it without knowing alam natin n times p yun, di ba? So without knowing that, let's try to solve it. So paano ba yung ginagawa? So all the possible outcomes in our sample space is from 0 to 10, right? And then, small x, ibig sabihin, yun nga, yung specific outcome. And then, 10 choose x, 0.2 raised to x, 0.8 raised to 10 minus x. Okay, so ibig sabihin yan, i-add mo lahat ng over 0 to 10, i-add mo yung mga values na to. Okay? So, medyo ano siya, medyo um, discrete math siya. So, pero pag ginawa mo siya manually or rigorously sa calculator, no, ang makukuha niyong value dyan is equal to 2. Okay? Yung 2 na to is actually equal to NP. Yung NP, yan yung formula ng expectation of binomial random variable. Yan yung general formula niya. Di ba? N here is equal to 10. Probability of success, P, is equal to 0.2. So, ayun. How about the variance? So, pinapakompute rin sa atin yung variance of capital X. Variance of capital X is equal to expectation, okay? Expectation of X minus expectation of X quantity squared. Pero may madaling formula for that. If you could recall the derivation for that, expectation of X squared minus expectation of X squared. Okay? So, mean square minus the square of the mean. Yun yung mas ginagamit natin na formula. So, for us to compute the mean square, we just summation from 0 to 10, x squared times p sub x of x minus summation from x 0 to 10, x times p sub x of x. So, we have already computed yung mean natin kanina. This is 2. So, we just have to compute yung yung mean square natin. So, we are able to do that by just summing up. Ayun nga, sinasum natin from 0 to 10. Pero in this case, x squared yung minumultiply natin dun sa probability values natin. Okay? So, ayun. If you do that, you would be able to obtain 1.6, which is actually the general formula kasi ng variance ng binomial random variables, NP times 1 minus P. Okay? So, this is the variance of binomial random variable. Okay? So, next question is actually an extension of the problem. Okay? So, letter E, so basahin ko lang. Suppose the marksman has to pay $3 to enter the shooting range and he gets $2 for each hit. Let Y be his profit. Find the expectation and the variance of Y. So, how do we do that? How do we do this? Nag-define tayo ng bagong random variable here, capital Y. Yung capital Y is in dollars. Yung profit na nakuha nyo. So, lagay ko lang yun. Capital Y is the profit of the marksman for that specific scenario. Okay, so from our high school economics, alam natin, profit is equal to yung revenues, which is yung kinita ng marksman, minus yung cost, yung binayaran ng marksman para makapasok dun sa shooting range niya. So in this case, kailangan natin, yung equation na to, kailangan natin gawan siya ng mathematical representation. So alam natin Y corresponds to the profit. So yung profit na to is in dollars. Ibig sabihin yung revenues in dollars, cost in dollars. So sa kada pasok niya sa shooting range, nagbayad daw siya ng $2. Ay, nagbayad siya ng $3. So in dollars, the cost is 3. Okay? And yung kinita ng marksman is in terms of the number of hits that he has taken. So it is also a random variable, yung revenues na yung kinita ng marksman. And it's actually equal to 2x minus 3. Okay? So for each hit, diba, capital X is the number of hits out of the stochastic experiment. He is able to obtain $2 for each hit. So 2x minus 3 yung ating equation. So, ang pinapakalculate natin is what is the expectation of Y. what is the expectation of capital Y and variance of capital Y. Okay? So, lagay lang natin yung equation na yun. Expectation, capital Y, is equal to expectation 2x minus 3. And we know the properties. Ang kailangan yung matandaan dito is the properties of our expectation. So, uh, the expectation follows superposition. So, pwede natin gawin 2 times expectation of x minus 3. So, ibig sabihin, we know this value, expectation of x is 2 times 2 minus 3, which is equal to 1. So, the expected profit of the marksman is $1 for each time he enters the shooting range. Okay? So, is it intuitive? Medyo kasi $3 lang naman yung babayaran niya. And at the same time, 'di ba, parang capital X dito is the number of hits. So 10 shots yung miss yung available sa kanya. And at the same time, medyo mahina yung marksman natin, 0.2. So, ibig sabihin, since mahina siya, konti lang yung kikitain niya. Okay, what is the variance of that? Variance of Y is equal to variance 2x minus 3. And we also apply the properties of our variance. So, i-review niyo siya. So, actually, this is equal to variance of 2x minus variance of 3. So, variance of a scalar times random variable is equal to 2 squared times variance of x. So, nai-square din yung scalar na nakamultiply sa random variable. And the variance of a constant is equal to 0. So, 4 times 1.6. This is equal to 6.4. Okay? So, this is our final answer. Variance, ang unit niya is dollars squared. Okay? So, kung gusto nyo, dollars rin yung yung unit niya, you have to apply square root, which is the standard deviation of capital Y. So, extend pa further yung problem. Let's assume that the marksman enters the shooting range for free and gets the number of dollars that is equal to the square of the number of hits. So, it is a same problem actually. So, lagay lang natin capital Z, which is yung profit niya, basically, nung bagong scenario na to, is equal to the revenues. Revenues daw is the square of the number of hits that he has achieved. Okay, so Z is equal to X squared, and the cost is free. Okay, so X squared minus 0. Okay, so how do we calculate the expectation of Z? So, actually, we are just getting the expectation of X squared. So, you can do that by the equation that I've shown earlier. So, it's doable in our scientific calculators. Actually, there's summation, but an alternative would be to know the equation of the variance of capital Z. Variance of capital X. We know, kasi alam natin yung value ng variance of capital X, right? Variance of capital X is equal to expectation X squared minus expectation X squared. Okay? So, for us to get expectation X squared, the mean square of random variable X, we just transpose this to the other side. So, variance X plus expectation X squared. So, we know variance of X 1.6 plus 2 squared. So, our final answer is $5.6 squared for the Sorry. Expectation of capital Z pala. So, dollars, $5.6 pala. Okay? So, so that is it for our discussion of this problem. So if you have more questions on this specific problem, if hindi nyo naintindihan yung discussion for this video, you can ask more question in our discussion forum in Piazza. So I hope that you are able to learn something from this video, and good luck on your classes. Thank you. Thank you, class.